Hey, Francesco or Francisco? How is pronounced perfectly?
Depends. When my wife is Francesco,
Okay,
and all the other people just say Franz. So
Franz. Okay,
yeah,
Francesco is the right way, and Franz is if.
Franz is the friendly way to call me. So Franz is fine.
Okay, Franz. This is a Bavarian name, so almost So then,
Yeah, I know.
okay.
I can tell you the story behind it, but only if you ask for it.
I'm asking now about the story about Franz.
Yes. So when I was younger, I was a breakdancer, and
Aha.
since yes,
And you are old now, but because you say no, if I
and
yeah.
old enough. Let's say
Okay.
that I've been 20 times 20 for some, and maybe a bit more.
Hmm.
So past 40. And when I was much younger, like 16, I was a breakdancer.
Uh-huh.
And for breakdance, the people have different nicknames
Hmm.
because I don't know why, they just love to have some nicknames.
Hmm.
And since I was very undecided to which name I should pick,
Hmm.
some other just say, oh, Franz. And I
Okay.
say, no, I don't like it. Why Franz? And another right after just passed and say, oh yes, Franz is great.
Hmm.
And from now on, from that moment on for till now, everyone just call me Franz.
Ah, okay.
So that's it.
The breaking Franz.
Yeah, I still break stuff, but code now. So
You can do still breakdancing or nothing.
no, thanks God for my bones. I got older for good reason because I stopped doing that stuff.
Hmm. Yeah, but I think you have still some moves, right? So you could do like moonwalker from Jackson or something like this.
Yes. Probably I can still do something,
Hmm.
but you know that I won't do at conferences, for example. But definitely I can do
Yeah, this is
something.
where I'm going with, because the next chat will be with Stefan Janssen, and so we could have actually, a breakdance show at the keynote.
It's definitely I can't do the same thing that Mario Fusco has done because I cannot cut more my ears. To be
Yeah,
honest, so
yeah,
that's
yeah,
something that I can do.
yeah.
But
Maybe
at
tattoo
least
then, in your case.
it's a tool. Yeah, I still have to be prepared that my wife is going to call me Francesco after that. So probably she won't be that happy.
No, 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 Franz. Keep Franz. But so we already learned breakdance with 16. The question is,
Yeah.
what was your first computer?
It was a Commodore 64,
Hmm.
actually.
Hmm.
And yeah, I mean, there was kind of a present
Hmm.
from my dad. I was like just walking with him. There was a small market
Hmm.
in which there was a couple of nerds actually selling technological stuff.
Hmm.
And he just say, okay, do you want, a little car, anything? And I just finger point to the computer and say, I want that stuff.
Hmm.
And just say, so what you think you can do with it? I don't
Hmm.
know. Just if you can, just take me and I will decide.
Hmm.
And it was something interesting because when I got home, I discovered that I needed a screen that was not obvious for me since I was very little. And I start to read this ancient manual in Italian because
Hmm.
starting from a certain point in my life, books were at least books related programming was not meant to be read into my own native language, just in English. No?
Hmm.
But at that time, there was the only way in which you can learn things because you needed translation. I was very small, and at the same time, there was no internet
How young
at
were
all.
you?
I was like 7, probably.
Okay. And
So
where
I
was
was
it in Italy?
where
Hmm.
in the place.
Hmm.
I live in Milan,
Ah,
so
Milan.
I
It
was
was in
in the
Milan.
north.
Hmm.
Yeah, it was in Milan,
Hmm.
and
Yeah, what's incredible? You wanted to have a computer, and your dad just bought it, right?
yeah, because we were walking in the street and was used, so it was pretty cheap for
Okay.
that. And it was interesting. I mean, it was big compared to me.
It was a used computer.
Yes.
Yeah, okay. I think
Yes.
you bought it in a market, in the store, a new
No,
one.
it
So
was
this is
in the
strange,
street.
So buy me this, and you got one. Okay, no, okay.
It was actually in the street, so we were walking, and there was this couple of nerd guys that was selling stuff that was or half broken, or maybe they were going to Amiga, for example.
Yeah.
Amiga 500.
500, exactly.
Yeah, likely. So, and they were just selling the old stuff in order to get maybe games for the new stuff. So that was pretty convenient for both, because I didn't have any, and for them, they got some money. And I think it was literally a game chain thing for me, because I discovered that I can type stuff on the keyboard and command the computer.
But why you remember why you wanted to have that? Why?
I think it was for some TV film or something like that. Hackers, I think. It was Hackers in the 80s.
Hackers, Hackers, war games? War games?
Yes, war games. And there was another one. There was another one that was similar to Star Wars, in which there was a coin-op, a guy that was playing with this video game and became part of the global defense stellar things. And because of the video game, I connect the dots. Okay, video games are made by programmers. So for me, they were superheroes programmers, because they were made.
Was it Back to the Future? No. They weren't.
It's so old. I don't think it's Back to the Future, because it was like a video game like Star Wars, and it was very Star Wars-like, with different races, with different stellar races, and related the universe. So, but I can't find it, because the problem is that in Italy they didn't translate just manual. They translate even the titles of those super nice, cool and films, so you will never know what it is.
Yeah, in Germany the same. Some titles are translated, so this is no trace back. Flash Gordon was, but it was a strange one, Flash Gordon could be, but it was a really strange one. Then the He-Man, something like this, but
He-Man remained the same here, the same in Italy. Yeah.
Okay, this was also a strange one. And Tron, it was also computer related.
Tron, definitely. So the thing is that the old culture of film was make me believe that yes, being able to create this universe that it will be awesome. The point is that when I was super young, I was commanding computer to do stuff, and it was kind of doing it. I don't know if later on I get the same feeling, because right now it looks like there is a kind of a single point in which the computer just doesn't do what I asked for. But that's a different story.
But for me, it was similar, because for me, I didn't have the C64 on the Spectrum, but for me, it was like a different world, It was a color, everything was possible, like science fiction on my desk, This was this is why I'm asking about the movies, because of a similar story here. Okay, so, and you started to program immediately, or played games, or what was the trajectory?
I started actually programming because I didn't have games yet. So later on, I discovered other friends that got the tape player. And other even with the disc, a giant disc for Commodore. So it was interesting that this square disc that you can put it and you can still play a game. I never got it actually. So my friends got it, because they have a new Commodore 64. Mine was the rounded one. So the one that has been probably, even recently, they made a small version of it.
I only know the rounded one. I don't. There was one.
There is another flat one, like more futuristic. It looks like the car of another film in which there was this light
DeLorean.
car. Yes, like a DeLorean. The kind of design was similar, and it was a Commodore 64 still. And so it was interesting. I mean, interesting period.
I didn't knew about that, because I only know the rounded one, and there was one up. It was not Commodore 64, rather than the bigger one, almost like PC. There was Atari and Atari ST, I think, and the Commodore was also
pretty.
Yeah. And Of course, Amiga 500, and not only 500, there was Amiga 1000 or something, right? So it was one, yeah, exactly. This was my dream machine back then. Never got it, but this was what I know, dreaming about.
There is always a dream machine. For me, it was the same. Amiga was actually Amiga 1200 was like, wow, I will never get it. Actually, I never get it. Probably I just have it emulated in my computer a lot of years later, actually, because I was curious to see how it feels to have it.
A nice story. So, and what you started to program with your computer? So, what you wanted to achieve, or how you started? This is interesting, the process.
In order to show something on the screen that move, very simple as it is. So, in my case, since I was so young, I didn't know about math. I didn't know about anything, but I knew I can draw pixel, and I would like to see them moving as I ask. Ideally, if
you managed to do that with the pixel,
because there was already that kind of program for Commodore 64 as an example. And there was another one in which you can basically generate a labyrinth and just create a labyrinth. So that was my very first two program that I made. It was fairly complex, but as I discovered later on, I never been great actually to create abstraction, to actually write code. But I'm very good to dissect code that exists and understand what it really does under the hood. And I discovered that I was like that probably even when I was children. Indeed, I was breaking pretty much everything I got on my hands. I break GPUs to see how they works internally. I try to replace the firmware of them in order to understand what can happen if I flip a couple of bits. I discovered that my dad wasn't happy about it because it has to change GPUs every each 2 years because I break something. But still, things has never changed that much. I try to break less things, but I still try to understand how
if you are a programmer, right, experienced programmer, and you get kids, I think these are hard because never touch a running system, right?
Yes.
So if I would get you as a kid, it would be terrible because I don't like to bother, with the low-level stuff anymore. I would like to focus on the more interesting thing. But if you would keep destroying everything, and I will have, oh man, I have to reinstall the operating system again, it's a hard stuff. I think if you get kids, it's better not to be programmer, right? Just technically curious, then you have fun. But as a programmer, you don't really like, to to fix already fixed things, right? This is
exactly.
really annoying.
That's a good point. That's a good point. Indeed, I never knew why I was having that attitude. But to be honest, it brings me a lot of interesting stories, especially with my dad, because my dad borrowed me a used video card, it was 3DFX, the first Voodoo.
Was your dad is a programmer?
No, not at all.
Okay.
My dad was doing other stuff, but was curious to see what I was going to do. No,
okay.
So he gave me this video card, and he told me, Francesco, that's very important. I'm giving this to you because I know that you love programming and you would like to play better video games. So use it wisely. And clearly, it wasn't my intention. So when I put it in the case, the very first thing that I discover is, come on, I can flash the firmware with that and make it a better video card. And then I discovered that I wasn't God. I couldn't create a part of chips that doesn't exist. So if you flash it with the wrong firmware, clearly it breaks. But I was so annoyed to tell it to my dad that I faked to have a video card for 2 months. So every time he was entering in the room, I would say, how is the new video card? I was faking to switch off the computer and say, Dad, I played so much today that probably I need to stop a bit. It was so
homework is waiting, right? I have to do like some homework right now.
Yes.
Yeah.
So it was fun. And later on, since my dad was probably way smarter than me, just say, Francesco, I know fairly well that you don't have any video card. So I appreciate that you try hard to not make me, know this thing, but I would prefer that you say that the next time what was your intention. So I can bring you video cards that doesn't cost that much.
Mhm.
And you can play with them if you're curious to know how it works. So my dad was very inclined to he was appreciating the fact that it was scientifically attracted to know how things work.
Mhm.
And thanks God I didn't have any pet, because probably we'll break the pet to know how it works.
Yeah, if
In
you
that
flash
case,
a
it's-
pet, you are in trouble, right?
yes. They told me.
Yeah. But the card was not on C64, right? This was later.
No, it was late.
Yeah. I mean, there was no way. Okay. So interesting part. I also wanted to move something, but I never managed to move a pixel. But what I managed to do, to move a character with basic. So
Ooh.
what I remember, it was really simple. You could pick a character, let's say the asterisk or hash or a or whatever, and just move it on screen. I don't know how. And what I also remember is they remained on screen, so you can draw them, and then you had the
Stay
like a
still.
snake of characters, and you could delete them by. And this was fairly easy, but never pixel. But and I also don't remember what I exactly did, but it was not that hard with characters. Okay, so and what was your program? So you just try to refactor existing software on C64, or wrote something which halfly worked, or what was the story?
But, at that time, you mean?
Yeah. Yeah, sure.
Yeah. So at that time, but the time Commodore 64 or later on, because
Yeah, 64. Let's close 64 story, and
Yeah,
then
yeah.
later.
Well, with 64, I always started with what I could find in the manual. That was just that two type of video game, and I literally move in a very randomic way at the beginning. So, like, okay, what happened if I remove this instruction? Because the problem is that the extraction was in English.
Mhm.
So sometimes you don't know what they do. I never managed to say go to, because since I was just reading the manual and I was a children, I say go to.
Mhm.
That is exactly what you would say in Italian.
Mhm.
So it was pretty fun. And by removing a part of the program, I observe what happened.
Mhm.
And if you think about it, it's a kind of empirical
Yeah.
scientific approach in which you have a system. You inject a new stimulus. You observe what are the changes,
Yeah.
and I keep on moving and draw my conclusion and read more
Mhm.
to understand exactly what I was doing. So, a scientific versus mathematical approach. That instead the latter could be the one that actually programmers should. In theory, programmers should do, but it depends what kind of programmer you are. I mean, if you use a chat GPT, probably you are in the one in which you just throw stimulus and see what happens. But
interesting. Your observation is really interesting, and I never saw it this way. And you think the mathematical approach is more like you have to learn the theory first and then start coding. This is like the mathematical.
There are a few ones that does like that. Clearly, they can adjust. We have the luxury that our environment, unless you directly write code in production, most of the time we have the luxury of perturbate environment without breaking stuff. So we can iterate through it if some of our even educated math guess doesn't apply. But the thing is that you can approach in a more empirical way, or on the other side having a more context of what things going on.
So interesting. What I do is if I learn something new, I start with the empirical way, right? So just to be curious and have fun,
to explore,
and then if you have in your head, okay, it worked like this, then it's for me very easy to learn the theory, because if I read whatever I read, I can just imagine and I can map it to this what I know. But other way around also works for me if I have no time. But then I have to read more. I read a couple of books about the same topic from different angles, and this is how I remember. And then if I start, then it works maybe, but then I have to go back and read it again. So both approaches are working. But I think starting empirical and then close mathematical and then go to empirical is maybe a little bit more efficient and more fun.
Yeah, I mean, an hybrid approach can then can help definitely, because it is the right mix. When you have a stopgap of some kind, probably you need to backtrack and try differently. And in that case, you can definitely leverage written data. The written data could be books, but not only. So because in this period, but even when I was younger, actually, so when I downloaded the very first time the Linux kernel, it was a Debian distribution, actually. I literally remember that I open a source code there and I say, what? I can read it? I mean, it's wonderful. And the reading code is something that even if I don't write as much code as I wish, but we can talk about it later, definitely I read tons of code. And reading code, and it's a good way actually to learn. Sometimes it's not the best way, but it could be very good if you have good reference, and even better reference, but if you're good to judge them. And that is the other thing, because broken code is the one which you can learn the most sometimes. So
what regarding books and ChatGPT and Stack Overflow, so what I appreciated about books back then is that the author, right? So if the author writes a book, there is usually some, thinking or a thread of thought or some personality, which I enjoyed. But if you just, learn from tutorials, ChatGPT or whatever, then you get just the information bytes and the entire thing is lost a bit. So this is why if I have the possibility and time, I always prefer books. It's just fun to read books, And you can also read books, if you're offline in airplanes or whatever.
That's true. That's true as well. In that regard, I try hard with the smallest ebook reader, but at the end I bought a bigger one, because actually
I had the largest
books,
Kindle. I had
the same. Exactly.
I had the largest Kindle. The first I bought with exactly.
Yeah. And when I go bed, my wife is not happy because it's giant. Actually.
Then Francesco, right? So Francesco, what they are doing?
Close your giant light now. Okay.
Franz, now it's okay. Cool. So C64. So you tried to move something. You created some labyrinth, and what happened then? So you just got the next one, or was it some?
I break it actually. So
okay.
What happened is that by removing relevant part to or construct the labyrinth, or just you start to see flipping in the wrong direction things, and you say, "Oh, come on, it's not what was doing before." So what's going on? Maybe there was actually a bit of discrete math to compute the speed of the character in order to move it in the right way. So if you remove stuff, maybe you jump every 2 or every 5 or every 6 different character instead of just one. So it is not as smooth as it was before. So what I discovered is that there was things to learn that is not just typing character. And the same things applies when I later on discover about video games programming, which you need to know a bit about physics, about optics. So it was a more interesting kind of discipline that I was expecting, to be honest. So like a word.
So you broke the entire machine, or you broke the
No, just the program. Just the program. I never managed to break. Incredibly, I never managed to break the Commodore 64. Incredible. It was a really robust kind of stuff, to be honest. So and I don't know, even the weight, it was pretty heavyweight.
Yeah, what I suspected, you overheated that, or you played with the data set. And to make sounds until the motor broke.
I actually overhit a Celeron. There was a Celeron called Celeron Mendocino.
I remember. This was the Intel for cheap. It was the Celeron.
Exactly, in which you can use a graphite, so basically just a pencil, to color a part of the CPU in order to make it to pass more data in some direction. So basically, I've done it. I exaggerated it over it and it
Hmm.
burnt basically. So it wasn't fun in
Hmm.
that case, but it was one of the many
You
cases of
mean
my.
this the pencil is like the it was like cooling glue, right? Between yeah,
Yeah,
yeah.
exactly. So, but it is what it is. So
So
it
what
is still
happened
fun.
after C64? You got the next one. Why you got one, or what was the story?
No, I actually had it for quite a long time. Then I moved because I was curious still out of computer for a couple of years and just doing console video games. So and I discovered that I was enjoying more watching other people playing and
Hmm.
observing the graphics that actually playing the game or
I'm the same.
understanding the logic.
I'm the
And
same. If I see a new game somewhere, a conference usually, I would like for 10 minutes observe how it works. Like, nice. This is nice. This is nice. It's enough.
exactly like
Yeah,
a judgment from outside because it's interesting.
yeah.
And at the end I say, okay, probably console video games are not for me. I would like to move again back into computer. And at that time probably there was the very first like 486 no
Hmm.
380 a
Hmm.
386 I
Hmm.
think was unable to play Wolfenstein 3D, totally unable.
Hmm.
And I remember there that when I was wanted to play video game, I have to free up
Wolfenstein.
through
I never saw this, but I think it's a precursor of Quake and Doom and stuff.
exactly
Uh-huh.
and Doom. It was probably the very first video game from Carmack, John Carmack.
It was
The
also from him. Hmm.
yes, yes,
Okay.
because the idea of using the maps that was actually coded in 2D and just make it with some math 3D was actually from him. It was
Hmm.
like a game changer for video game at that time.
He's also the creator of Oculus Rift, right? So of the 3D
Yes,
goggles. Hmm.
yes. Now he is definitely a brilliant engineer.
Hmm.
I mean, I had the chance to read the black book of of Doom, if I remember correctly, with the source code of Doom, including Doom 3. It's an awesome
Hmm. You read the
engineer.
entire Doom code? No.
Yeah,
You read?
yeah. When I was younger, yes, and I made the same with the
Wow.
Doom with Doom 3 when they make it,
Mhm.
and in a recent conference, it was recent, let's say Rivera Dev. There was a guy that ported the Doom 3 in Java,
Wow.
and I was one of the few attending the conference. And he say, "I don't know, guys, if you know about this game." Yes, I know everything about it. I was so curious to know how he
Mhm.
was able to do it. And the thing is that I never stopped with that thing. So games was just a starting point. Even now, when uh, when I have the luxury that something is open source and is pretty common these days, and I know the authors, I know that they are good programmers. I really want to know what they've written,
Mhm.
how it works. I spend a lot of paper driving, drawing real buffers or what else to better understand the logic of the
It's
things
interesting.
that I
So never look
observe.
at my code because I have lots of code on my GitHub, but completely different, right? So what I think, what I'm doing is I try to write simple code, even if it is not efficient, So it is better to write simple code and remember what you did after years. And if there is a problem, we can always optimize, right now. So this is what I completely changed my attitude. So if you will look at my code, my examples, I think they will be terrible for you because it's okay. What he's doing here, no, he writes. If you would use a different method, it will be faster. There are always exceptions from rule. For instance, if you use regex in Java, I know that is slow. I cannot do this everywhere, but I know, okay, this is good enough. Just it will work, right? So this is.
Yeah, for me, I mean, I literally along my whole career, I move in different direction
Mhm.
about appreciating
Mhm.
different patterns in code, the different coding style, and what I discovered so far is yes, I became too much biased about what actually happened under the hood, but at the same time, it was exactly what I was looking for when I was really a small children. I wanted to look at the code and not guess, but have a very precise idea of what happened till the very last bit in the pipeline of the CPU. Was exactly the kind of control that I needed. And I discovered so far that in order to achieve it, yes, sucks me a lot of time. Sometimes I don't get it fully as I wish, because modern CPUs are really complex nowadays, but still I spend a fairly good amount of time to understand how it works at the microarchitectural level, and the compilers and what else in the middle, literally. And still, I never managed to write code that was simple and still make the CPU as happy as I wish. But I discovered that it was a lack of skill of mine, because I discovered there were actually programmers around the world that create abstractions, but in the best way you could ever. There was good abstraction to describe a domain. It was good for performance as well. And this kind of things is pretty rare, because the people always talk about trade-offs about it. But I believe that there are humans, very few ones, believe me, very few, that are capable to do both at the same time. And for me, it's like observing a god. Wow, it's incredible. They really do it. And there are tons of examples of that. Clearly, I'm talking about very specific products in which effectively performance was a relevant factor. But still, there was not given for granted that the code was looking so good. And they actually make it. And one of these programmers is actually Martin Thompson, for example. So he's a very well-known programmer in the computer science world. But what I discovered so far, and that was interesting as well, talking with other people, is that that code was looking good to me. Because actually, the good code, you can express in different way what are the quality of metrics that make it good or bad. There are some that are definitely absolute. So having 1 million of lines of code for a single method clearly is not a good idea. But at the same time, there are others that are very personal kind of qualities. And I discovered that that code was looking so good just for me, because when I talked with other people, they told me, Franz, you told me that this guy can write code that is as efficient and as good. Why you say so? So he's not that good. I would write it completely differently. And that's good. I mean,
what's interesting is in our conversation, you are more like, the platform engineer, and I'm more like the application business coder, right? Definitely. And in my area, what I see is lots of enterprise business developers are really concerned about, low-level Java optimizations, and they forget database I/O or backend system I/O, and they save, 1 millisecond in Java and lose 10 seconds with database interactions. So, if in business environment, I would say, what I think is what is a good strategy, starting strategy: write simple code, trust that Java will optimize the code for you if it's simple. Don't try, to pull cache, whatever. Just write simple code, and then spend more time on I/O and think, where I am blocking, what is the timeout, and what you are doing with the external system. So this works better, but this is completely different strategy to what you're explaining right now, because I think the difference is that in most enterprise apps, I/O is actually the problem. So you're waiting for interactions with external systems.
Yeah, because actually these are like two different kind of jobs. Because in one case you write the infra code
exactly.
that is actually the database. So you don't have much beneath you. Yes, you have the I/O disk network, but it's actually you that are in charge to be efficient. On the other side, you are the users of these other stuff. So, but all these two different jobs still can make use of the same methodology, pragmatic methodology, to understand how much is it worth it to invest your time in which part. And there is a name for that. It's called use methods. The use method stands for USE. And the use method is coming from Brendan Gregg, that was a performance engineer in Netflix, and later on now he's an Intel one. And he's a methodology.
He's also a Kubernetes guy, right?
I think container virtualization.
Yeah, exactly.
And this guy say, okay, when you have to approach a problem in which you don't know what's the limiting factor of your application, you need to check literally each resource, check if there are if there are no errors, because if there are errors, probably you are measuring a broken system. Then you should check what is the resource that you use the most, and which resource is not actually enough to deliver work. And that will help, because if the people find out that in order to perform a database call interaction for a business kind of related work, the actual part that is under stress is not the Java side, but it's the DB.
Yeah.
Probably.
Yeah,
That's
and
where
Java
you should focus. No?
Java becomes to be on the stress side, because what happens then if your blocks are threads are blocking, and this is your before loom, then you get out of memory and out of resource problems, which are related to the backend throttling.
Exactly. Well, but still, even in this topic, I discovered recently. I mean, I've been a bit horrified by it, because it was way different from the world in which I started to care about performance. I was used to a world in which the people overcharge their application, so they grant a huge amount of resource to application in order to receive alert that something is off only when you approach like 40% of utilization. So in that case, oh, come on, the world is on fire, let's do something. Because they literally provide over provision the machine. But now the world is much different. So I discover a bit horrified that since the people strangle resources to the application, regardless of which framework they pick, it could be Quarkus, Spring, Halid, whatever. I don't care. The point is that they basically put the genie that is actually Java in the bottle.
Yeah.
And when they do it, and the bottle is too small, there is no oxygen, and it dies. So, and in that case, what you do on Java side could become relevant. But it's not because it's relevant. It's because the context of how we are used to dedicate a resource to application that maybe would like more resource now became so few that if you make something wrong, you pay infinitely worse than it was before.
Yeah, I'll give you a concrete example for that. I run Quarkus as serverless on AWS Lambda. So, and what I observed in the past, that project wanted to save money and said, okay, we run Lambda with 128 megs of RAM.
Yeah,
which is fine for Quarkus, because it usually consumes not even on Graal like 90 megs of RAM, so it is no problem here. But with 128 megs of RAM, you get 1/11th of a CPU. And Java does not run well on 1/11. So what I missed the point that you can only buy the CPU with RAM. So with 1.8 gigs of RAM on AWS Lambda, you get one full CPU, 1769 is this RAM. And this is the sweet spot, because, of course, you have far more RAM than you can consume, but on one CPU, Quarkus runs absolutely okay than before, or Java, not Quarkus. And you can actually save money with the configuration. And the side effect is we have far more RAM than we can actually consume. And, project asking, so why are you running so much RAM? I could be, because I need one CPU. And this is
to get it.
Because the cold start is the shortest, and the performance is the best. And we have plenty of room, and so there is no need, to optimize RAM memory, for instance, because, and also funny fact, because the serverless, in one point of time the Lambda gets killed. So it's actually, we could even have, memory leaks and no one would care. Of course, we don't do it on purpose, but this is less relevant than in container or Kubernetes. But I'm already curious. Actually, this conversation is already too interesting for me. So we have to be careful with the time. But what makes me curious is, what was your next computer after the console, and why you bought it, and how you got it? So this is interesting.
Yeah,
386. You said this was.
Yeah, it was a 386, still a used machine from a programmers actually again. And he basically gave me Borland C compiler with it, probably, and a Delphi 3 or 4. It was pretty old. I enjoyed more the C1, to be honest. But I mean, if Delphi was capable to be more visual, because actually interacting with anything that looks a bit graphical was really a mess at that time. It wasn't easy at all. And it was less interesting than I wished, because there was too many layers. already. And since there was no way to know what Windows does,
Yeah.
it wasn't that fun.
So was it Windows already 386? This was Windows
probably
3.11.
3. Yeah, it was a pretty old version of Windows, and I wasn't happy about it. I was mostly using Bash, to be honest. But the reality is that I start to look around and see if there was an alternative of something that I could have. I was kind of control freak, I would say. So I wanted that control, and the Linux was like the sweet spot. But the point is that there was no internet. Probably I just heard from these programmers that sell me the computer, and I've been able to download the very first version of internet much later on. It was like with the 24.4 modem while I was 17 or
Robotics.
18. Yeah, a US Robotics, a Win modem. So I was able to use it only on Windows, because when I downloaded Linux, I installed it. There was no dual boot, no way to get back. So because Win modem wasn't supported. So my next
You did in
option,
Windows, what I remember, was like slip, right? So what I did, right? So there was the German, I think it was German, like remote connection. And you could create a shortcut, and if I double-clicked, the modem worked. So I remember this was the also interesting automation back then.
And it was super noisy.
US Robotics with button, brown modem. But the name was cool, US Robotics, right?
Yeah, the name was actually a good name. I mean, probably at that time they didn't care as much as now with marketing, but definitely US Robotics was very attractive for developers and programmers.
And German modem at the same time, I remember, was called Elsa, I think Elsa. And this was a terrible name, if you compare Elsa with robotics, who would like to have Elsa, right? So
it's terrible. Yeah,
so you downloaded Linux. I did a little bit later, did the same. And what I discovered, Minix. You discovered Minix?
Minix. There was probably when I started university, they tried to teach Minix and Qnix. It was both. Qnix probably later on, the second year when I was in university, but Minix was the very first one probably they talked about. But I discovered a bit earlier Linux as well, so I was more used to Linux. I mean, more used is a big word, because even now is not definitely the year of desktop. Linux has never been. But when I was younger, I was really believing in it. And I still remember that I tried Mandrake, different distribution at that time, Gentoo with stage 4 compilation, all the crappy way to install stuff, not install, compile everything, because
I remember a consultant. So we worked already. So this was like 10 years later, and the consultant had 2 machines, and one machine did, and the was hot and run the entire time. It's like, what are you doing here? And it's like, I'm compiling the Gentoo. It's like, why?
Exactly.
Why are you doing this? It's like, because I would like to have the optimal distribution. It's like, but why? I mean, back then I used Red Hat already, because I like the Red Hat. I don't know. The entire packaging for Red Hat and everything looked far more professional than all the other distributions. I had actually only Red Hat and SUSE. This is both. I started SUSE, Red Hat. Both were very shipped, with nice books, with nice packaging, CD-ROMs,
and nice UI.
Nice UI. But Red Hat was a little bit nicer. And what I remember back then, I think Red Hat came with KDE or CDE, which I really appreciated because it looked like the HP Unix.
Yeah.
And it was really beautiful. And I always wanted to achieve exactly the look, which was not simple. So I used, I remember there were window manager would look like Windows back then, Windows 95. There were no different Moon manager or whatever. This was and this is what I also appreciated. Again, right? It was like small science fiction in a box. With Linux, you could have so many possibilities, so many UIs. Earth, you remember? There was a possibility to have 3D Earth as a background, which moved.
Exactly. Yeah. And you can even have a 3D desktop in which when you click to change desktop, it was rotating a cube. And I was super happy. It was my first discovery around the OpenGL and Mesa Drive driver and having the right hardware, because the point from that moment on for me was to find the right compatible hardware that was just working
And my
right
first Linux
with the
installation, they asked me for the chip number. And I say,
Who
how to
knows?
find the chip number? So I have to deconstruct the machine, and I try to find the number. So wrote it down. Right now I would take a picture, but back then you have to write down, reassemble it, come back and write the chip number of the graphic card, what it was, in order to make it work.
Yeah, because they basically have precompiled settings for X for the server. No, I mean it was an interesting period, but it was a period I was spending a lot of cycles by breaking stuff myself without doing anything wrong actually, and just because I updated to the newest version of something. And I was saying how much that could be so painful to have a computer just to use it.
And you never destroyed master boot record?
I literally done it so many times.
Yeah, exactly.
Well, yeah, and it was done when you got it. Yeah. No, it happened the same. But it was my very first encounter with the Linux OS level programming, and I was shocked about forks, vforks, network programming. Everything was a file. It was so much better to not knowing anything as I was used to with Windows. Not because Windows was bad. I played video games for many years in Windows. But the reality, if I would like to know more, I couldn't. I couldn't ask to anyone. There was no way to know things. In Linux, you can do it. You have the source code. And at that time, actually, there was a good reason why I was compiling from source code. Not because I wanted, because it was so slow internet. And it was the easier way to compact, to compress sources and download over internet during the whole night, actually. But it was still capable to download something, because with binaries, it would be fatter.
Yeah, you are right. It's a nice compression.
Exactly. And it was the period in which they created the TGZ. So it was incredibly like a few megabytes just to have hundreds of megabytes of source code. So it was actually very nice. And I didn't know about Linus Torvald. So there was the author on the source code. But for me, until I got to the university, I didn't have time to search for more information.
Because of breakdancing, right?
Yeah, breakdancing was the other thing that I was doing at that time, and it was sucking a lot of time, like 4 hours or 3 hours of training a day.
And was it a structured training or just dancing?
I mean, when I was so young, breakdancing was early starting in Italy, and it was on the street, and there was no structure, because something that I learned in breakdance that I used even in my computer science related work is to be able to steal with the eyes. So be able to observe, understand, dissect, make it yours, and make it better. So, and it's something that could be used in many other disciplines, actually. And having open source help. With the breakdance, you just have the eyes.
And and breakdancing, everything is open source, because you can look at the others, right?
Exactly. And it's all that. There are no secrets. The only secrets is to train in order to get better, and to be better into understanding how to adapt things with your body. And that's it. So, but it's not any different, because when you learn how to code things, even by reading book, you eventually end up not just adapting yourself, but adapting your coding style in a way that it works very well with your brain and others. Ideally, you would like it with all the rest of the world. But if it's as good to be maintained by you, and you are actually the one that mostly maintain it, sometimes you pick that choice as well. Even if it's not the best one, it could be as pragmatic that recognize that you are the one in charge and responsible for that piece of code. So better for you that you adapt it in a way that you can read it, understand what it does.
But in Linux, you implemented driver level programming, right?
Yeah.
And what you did, I mean, you wanted to understand it, or you wanted to implement something?
It was for necessary, because I had a Win modem, and I really want to make it work.
And it worked?
No, never.
Okay.
Never. But later on, someone published a driver for my same for my same modem. So I had the chance to compare, and I say, oh, okay, probably I need to learn a bit more about network programming. And it was very young, so it
Uh-huh.
was my first encounter on it. But when I get
So what
that,
were your mistake? So like, sockets or whatever, or what was?
there was sockets level programming that was
Mhm.
really bad for me, because it was assuming something that later on probably they write in Thai book, not trust the network. The
Okay.
network is not trusted. In my own decision is, I send something, it's going
Yeah.
to work. Why is not? And clearly wasn't the case. So and the same for DMA kind of programming, because when you write to driver.
Direct memory access, you mean?
Exactly,
Hmm.
because with drivers, sometimes you get a matrix of different register of capabilities exposed by the hardware, in which you can memory map to them. And from a C perspective, is as simple as reading from an array.
Hmm.
But you're actually not reading from an array, but a special memory that you keep in sync
Hmm.
directly by the lowest possible level
Hmm.
of hardware. And in that case, uh, I learn how to break stuff in many different ways, because then you have to care about handedness, you have to care about the memory ordering and fancies, things that later on, when I work in many different fields. One of the fields was IoT. So I was writing directly without operating system in assembly for IoT devices and IoT routers when I was, later on in the job field. And
Cool.
all that kind of knowledge was just working right, because I already learned that
Hmm.
stuff. And actually, I discovered how much I preferred assembly, because assembly was making me able to control more what's going on. While with compilers, you need to check in the assembly and check what's going on and compare with what you expect. And maybe you forget just to put a barrier that prevent the compiler to move that specific code and optimize it away in a loop. In C, you can do it with actually explicit memory barriers or volatile. And later on, when I moved to Java, that looks a high level, I discovered that I had the chance to peek again under the hood and understand how things look like. And even now, one of the biggest selling points, and you would be surprised how much could be impactful in the real world, that skill has paid off immensely. And when I say immensely, I mean something that we talked about just 10 minutes ago about containers, for example. No? We talk about containers with scarce resource. And I discovered something that it's a kind of disclosure. I'm going to publish very soon an article on this subject. Basically, I discovered a massive scalability issue on the JVM when you don't dedicate enough resource. Because when you don't dedicate enough resource, since the JVM have different tiered level of compilation, there is two of these tiers that are called tier 2 and 3 that inject, because the hotspot compiler, as the name suggests, work on hotspot. And hotspot require telemetry, because the JVM would like to learn more about that code that is running, inject telemetry. That telemetry use shared counters across different threads. So if you don't dedicate enough resources to your container, you start, you receive some load, the compiler would like to compile something, but since it doesn't have enough resource, it slow down. Since it slow down, the code remain at tier 2 and 3, and you got the scalability issue in. So what happened is that if you have an elastic pool by their own definition tends to grow if they cannot succeed to dequeue in time the task they receive. But since you have these shared counters hidden in your code, the elastic pool grows immensely, and it slow down more the compiler, and the old pod can be pod container is not important, became unresponsive for 10-20 seconds. It's a massive scalability issue on container for Java. And it's pretty interesting because I learned about it just because I know assembly. Because the only way in which you can recognize what's going on, you need to learn about CPU architecture, how caches work, how the cache coherency traffic work. And definitely, if you want to troubleshoot it, you cannot rely on profilers because profiler will blame a method. You take a look at the methods and find out that the method is fine, was stupid and simple. What's going on? You need to go one level deeper. And that level deeper is exactly.
So what you said is because the containers don't, if the container doesn't have enough resources and Java runs inside, the Java C compiler won't compile good enough, and because it doesn't compile good enough, the pool will grow, the pod becomes irresponsive, it gets killed, and new pod is started, and this is the scalability issue indirectly, right?
Yes, because the counters that are used by the hotspot are shared. So every single Java thread that is running this suboptimal compiled code is going to update these shared counters in order to let it just in time later on to have that information. But that later on becomes too late.
I think your knowledge is extremely valuable because there's also another area where you can, very hot area where I thought you will go in this direction. It's called WASM, right? So you can have assembly-like programming in JavaScript and in containers. So there's also a trend that the containers can run WASM directly. And of course, the next question is, wouldn't be nice if Java would be compiled directly to WASM and run on the edge, indirectly as. So I think your knowledge is very valuable. And what also interesting is my impression, complete different topic, but with the LLMs and Gen AI and all the AI experts, I think what will happen is that either you have no idea what you are doing and try, to the extreme empirical approach is just, to write something which works and you don't have no idea why. And or you have the deep knowledge, and with the deep knowledge you can optimize stuff, and with the Gen AI you can achieve incredible things. And of course, my impression is as well, in 2-3 years we get a lot to do, to clean up systems which were generated by AI, and no one knows what they are doing right now, because I don't think it is possible that a LLM or AI will generate complete systems, because for me still, Gen AI is a very good code generator. But you have still explain what to build, and you have to be very specific and observe what is built, test it, and if it doesn't go in your direction, reject it completely and do it again. So I would say you have to have even deeper knowledge, because you have to know what can go wrong, whether the AI goes in the right direction. Maybe you were misunderstood because your prompt is incredible power. So you have to put into 5 sentences the knowledge of the entire system and observe the outcome. And this is the next challenge. So I think what will happen the next years, now people like you are very valuable with deep knowledge, and the middle ground maybe a little bit problematic, right? Because so this is also interesting. But Franz, your study, what you learned during your university, what you learned is because of breakdancing. You had no time for computers, and then university happened. So this is not interesting.
Yeah. It was a bit of a funny period for me, because it's something that I can tell that was valid in the first years of my university, but had never been as valid as the later year. Basically, in my family, we are, I'm not joking, naturally skilled in math and this kind of science. So my cousin is actually one of the maximum expert on the superstring theories, for example. I'm not joking, literally. My family is very good in that stuff. So the first 2 years, I literally didn't study much at university. I was able to pass exam. It was probably the worst idea of my entire life, because I never managed to sweat, to suffer in order to get something. And when I've been in the third year on the other side, you're required to study something. And I wasn't used to it. So I was literally like a very free person. I study what I like. That doesn't work in university, that stuff. So I learned discipline. And it teach me enough that probably the most valuable part is to be an art worker instead of to have just talent. And the talent of math just disappeared with the years because I stopped using that much math. I was using math in the form that I needed for my job, and that's all. But what I learned so far in that period is that I love to study, even if at the beginning it was, a bit not easy for me to start from scratch because I started. My very first year was the third year. That's it. But in that period, and that's the funny part. I study AI a lot because I wanted to be in the computer science field for video games, and there was not many options at that time in Italy. There was no video game courses like now, and I have to pick one of the part, a few in which I could get others to teach me something that I could reuse to make video games. And since the graphics part, there was no courses.
Mhm.
For the physics part, there was no courses. But on AI, yes. And in artificial intelligence of games at that period was starting to
Mhm.
be used. So you start to have Quake with agents. You
Mhm.
start to have Black or White. There was a video game in which you train a pet and that pet learn for
Okay.
real. And it was using real reinforcement learning and neural networks. So I get very good in that thing. And at the
How are
same
they
time,
called? Tamagotchi? No,
Tamagotchi.
Tamagotchi. Okay.
Similar, very
Yeah.
similar to
Yeah.
Tamagotchi, but you basically educate a god by making other people to believe in you in this godlike video game. And there was a pet that was observing you and learning from what you did. And you
Mhm.
got different inclinations, so you get good or bad, and the shape of the environment change accordingly. So I get very passionate about the artificial
Okay.
intelligence part. So I
Mhm.
became better in statistics, and at the same period, I was really not so fully convinced about what could be my future
And very
because
good in matrix multiplication, I think, right?
yes, definitely. And with robotics, there are no other way. And the interesting part is that I got very good in AI. And on the other side, I was very attracted to compilers.
I have to laugh. Sorry, I have to explain it why I'm laughing now because
Yeah, just shoot.
matrix multiplication. So in math exam, we had to do matrix multiplications, right? And you have to be very careful, and there were large numbers. And what I did by mistake, instead of taking the calculator with me, I picked the remote control of the TV because they were very similar, And then the exam, I still didn't recognize.
Yeah,
And the
there was
professor asking
giant
me, what do you
calculator.
need this for? It's like, what do you mean? I was like, oh man. And he was not allowed to give me a calculator. So I have to perform, the matrix
Math,
calculations, really, multiply, because you have to multiply a row with a column, right?
row
So
a column, yeah,
yeah,
and
exactly.
sum.
Yeah, and I had to do this on the with a pencil, and I was too slow, but it was not a disaster. Let's say it this way, right? So, but I was really sweating, so this is why I was laughing, not because of you. Just I had to clarify that. Okay.
No, I mean, it was an interesting period. In that period, I get very interested into compilers
Mhm.
and artificial intelligence. But I end up actually, so I am a PhD in AI. That's the funny part. And I discover after 2 years working in a research center, oh, this AI stuff is not really going anywhere. So make me change my job.
Okay.
And I start to work on the IoT fields. And returning back to my interest into the compiler side of things, and I never left it. So
And which programming languages you learned in university? C.
C was the very first one with Unix programming, but right after it was Java.
Ah.
Immediately, it was a very modern thing. To be honest, it
Mhm.
was nearly at the period of Java 1.3, I think.
Okay.
1.3. So there was still, raw edges. If you try to use a IDE, there was J.
Builder.
Yes, I think so. And they
JBuilder,
needed
Semantic Visual Cafe.
Yeah, and I needed to switch off all the windows in order to have enough RAM to run
Exactly.
it on my computer. So it was terrible, terrible, but still, wow. And later on, there was Eclipse actually. So
Mhm.
Eclipse was pretty
Since
early. It's
2000,
so many
Eclipse
years.
was very good because Eclipse was able to refactor stuff with JBuilder was terrible.
Exactly, exactly. And I remember that I've been a fan for a few years on NetBeans, for example. I
Yeah,
don't know why. I like it.
I
So
was a huge NetBeans fan, and what I like it
good.
before it shipped with all the plugins. You could open and be
Exactly.
productive. And Eclipse was
Yes.
terrible because I was always a consultant, and every of my clients had own plugin sets and own distributions. And I never could use the same IDE for more than two clients. And NetBeans was perfect. I just opened and it worked. So
Yeah.
for me, it was it's like the productivity tool. Like
Exactly, and UIs. I remember that I started with the Swing when I found that in Eclipse you don't have the same luxury to have the dialogues to write stuff, design stuff, and you need to go through the SWT or
Yeah, exactly.
AWT
RCP.
native
Mhm.
one. Maybe it was more performant, but the reality is that for me it was unpleasant as a programmer to use it. So I definitely prefer NetBeans. But
Mhm.
with the C++, it was a different story because in that period, C and C++, there was plugins for Eclipse, so I can use the C++. It
Yeah,
was
exactly.
bad, but I can still use it. While on the other side, I couldn't. And there was a couple of other C++ IDE for Linux that were for GTK developers.
Mhm.
So it was actually the one that write
What was the
the
name?
UI part.
Because you remember?
Uh, Let me think about it.
Because I think they were also distributed with the Linux, and you could optionally buy also a license. This was a half open source, I remember. And
I have to think hard about it
yeah,
because since it was still too much heavyweight for me, I end up using for a few years Emacs. And the
of
Emacs
course.
was complex for me because of the fingers you have to
Yeah.
remember. I mean, not as complex as using Vim that I never get to be good because I found out later on that I have a very selective memory. If I don't really want to learn something, there is no way to put it in my head. Maybe it will work for 1 week, and after 1 week and 1 day, I basically forgot everything.
So you
Like
have a
I
good
never
garbage
done.
collector then.
But definitely good. So good that there are no traces about.
Exactly. No scalability issues in your case.
Yes, my wife is so surprised about it and say, "Oh, come on, we talk about it." Really? I don't remember anything. I don't even know if I was in Italy two
No
weeks
Kindle in
ago.
bed. So no, never. Hey, and what is your title of your PhD?
Was reinforcement learning.
Wow.
Uh, it was reinforcement learning comprehensive merging with the neural network for the reduction of the candle distance or something like that. It was
Candle
a
distance,
very
no idea, but
uh,
interesting topic. Still up to date right now.
yeah. I mean, at that time, since neural network was are even now likelihood estimator, we wanted to bring reinforcement learning to make use of it as part of the chain, both to train and use them.
Mhm.
And there was no papers for that at that time. So part of my process was to make it happen. And
Mhm.
the reality is that I don't remember anything about it. I
Mhm.
remember there was a lot of statistics, a huge amount of
Mhm.
statistics in that, mostly statistics. But as I told you, I have so much selective memory that since it didn't turn out to be useful for the rest of my life, I literally erased all that part of my life. I know that I work in that field. I know that I study a lot of that field, but I'm very good to forget and just focus on the new things that I really
Okay.
care about.
And
I
what
don't know
happened
if it's a skill, actually, to be honest.
after your PhD?
I try hard to still work in the university. The To be honest, it was very hard because the money was very few,
Mhm.
and I work in the laboratory for like 2 years,
Mhm.
another 2 years, and then later on I tried to get hired by a private research
Mhm.
center that was in an hospital.
Mhm.
That was San Raffaele Hospital in Milan.
Mhm.
And in this hospital, the research center was paying a bit more. And the work was very interesting because they were working on medical devices and they still needed to use AI in some form,
Mhm.
in a different form,
Mhm.
let's say. So I worked a bit to the Leonardo surgery
Mhm.
robot at that time. And since it was a research center and it wasn't focusing just on AI, but all medical related things, there was many other initiative and project, European project. Some were related vending machine that can recognize what you do
Mhm.
with utilizing OpenCV, for example, and based on that react and do
Mhm.
things for you.
Mhm.
So that's the very first part in which I returned back into the IoT
Mhm.
embedded stuff because there was Windows CE that was running the controller or the vending machine, and we didn't have three developers. It was just me. So I had to do the work on the controller to look at what was the messaging moving in the serial, talk with the vending machine vendors, look at the register, use a C sharp because C sharp had a very good integration with the C++ and native stuff and was Windows CE.
Mhm.
And then when I work at that project, I later work in a project of medical data, streaming of real time medical data that
Mhm.
was similar to HFT, kind of, because a huge amount of data, all the data is critical. And I start to approach working with a few of the people that were actually working in the HFT field because they published libraries that were useful for the kind of work that I was doing. One of these library was Chronicle Q, made by Peter Lowry, that
Ah,
was a kind of Kafka,
yeah.
actually, because it was a Kafka on the disk with the memory map file, and all the knowledge that I get in the other parts of my life that I didn't forget for some reason, probably because I make it in my hobby time. It wasn't my job. I remember fairly well. And I could reuse it for that. So I started interacting with these people. I learned about the Disruptor from Martin Thompson that
Yeah.
was
Which was a ring
used
buffer, crazy fast ring buffer. Mhm.
exactly. And that was the game changer of my life because when I learned about it, I say, but I know concurrency.
But this is crazy. We have to
That is
explain to
fun.
the listeners. So the
Yeah.
Disruptor it was built for the London Exchange. How to call it?
LMAX.
LMAX exactly. And Disruptor, what it was a ring buffer, and you wrote your bytes to the buffer, and were read on the other side to prevent random garbage collector runs. This was actually this, right?
Exactly. The concurrency pattern in which he was able to do it was completely lock free and super innovative. And the interesting part was that was able to perform multicast. So actually, you can have different readers that doesn't consume each other the
Mhm.
message, but the message is spread to all of them.
Mhm.
And the actual thing that was super surprising to me, it was in Java. It was hell fast
Mhm.
hell fast, more fast than I could expect. And this guy was talking about mechanical sympathy.
Mhm.
And when I learned about it, I say, that suit me very well to me because I want to learn what's happened under the hood. And when I start to read about how concurrency work, the work made by other developers in the concurrency field, like Nitsam Vakard, it made this library called JC Tools that was made in order to have the replacement of queues,
Mhm.
concurrent queues in Java, in order to be as fast as the Disruptor, even more. I start to contribute and get in touch with these people. So I send email, I
Oh. Mhm.
exchange books, I ask for knowledge because I wanted to learn more. And all of these people has been super kind to me because they all answer that you cannot give it for granted because he's a random anonymous person that write you an email and just ask for information while your job actually is to get paid for
Mhm.
that information. But they recognize I was really curious. And probably if they didn't tell me, I would still do it the same. And they eventually say, okay, let's make this guy happy. Let him make it become better since he want to learn more. And they gave me material. and I start to be a contributor of GC tools of the Disruptor, and I eventually get better into that part. And then I say, okay, maybe I can step up and say, let me take a look at the OpenJDK code that was on Mercurial at that point, at that period of life. And I started reading myself the whole OpenJDK code. So when I eventually, after many years, I became a Red Hat developer, and I get in touch with all the good candy stuff that I wanted to eat in my life. I want operating system. I want a disk. I want the working. I want OpenJDK. I want compilers. All of them, all this stuff was packed in a single company. That was even the one that was shipping one of the Linux distributions. So for me, it was a perfect fit, and I could reach out everyone, because everyone in Red Hat, if you drop an email, they likely answer to you, and you can get a call.
So how you joined Red Hat then?
Yeah, it was a funny story as well. So I'm a very stubborn person. I really wanted to be in Red Hat, but the point is that since the most of my work was literally unknown, because it wasn't open source, when I had the very first interview was for a job in C. It was about writing a router in C that was exchanging data with the AMQP protocol. So I had this conversation with one of the lead there, and I said, yes, but the problem is that AMQP is low. And he was kind of surprised by this, sentence, and say, okay, can you show it? Yes, I can show it. And I had roll out my own binary protocol, to be honest, that is not credit based, is back pressure based on the other side. So you don't ask, you send, and then you get information later on, because nowadays it's not a problem. You have enough bandwidth. And he said, I don't really believe you. I mean, you are so young. How is possible? I don't think you have done that stuff. There is any source code. And we end up that I got rejected. So what happened later on is that I say, okay, it didn't work out, because he said that actually he couldn't believe. So let's decode the talk. And what I've done is that I search one product in Red Hat that I think I could fit. There was actually the ActiveMQ Artemis. Let's say that the next Hornet Q at that time. And I picked the old source code, and I basically rewrote the journal in order to be memory mapped, similar to the Chronicle Q product made by Peter Lowry. And I implemented this thing for Scratch in 1 month, and I sent a patch. The lead reached out to me, say, I don't know who you are, but I think you could join Red Hat, but let's have a chat with it. And was clever. There was one of the lead of the project, a very good guy. And the thing is that it wasn't enough, because the first time I got rejected, but I didn't have any power to have, a conversation in which I could decide more what could be my role. So in order to get there, I say, okay, there are other places in which I would like to work. Let's have more than one option and see what happens. And at that time, there was one company. There was Hazelcast. Hazelcast was working. Okay, so in Hazelcast, I noticed that they were asking for developers skilled and experienced.
Ozark Turk, right? Ozark, it was.
Exactly. So, exactly. So what has happened is that they publish the request for a new figure on the performance side to work with Peter Ventier, that was one of the lead in the performance field there. But I couldn't fit the requirement, because since I never got anything open source, no one know me. Why they could believe me? So I risked to be in the same situation. So I drop an email to Peter Ventier, a long one, in which I say, Peter, I know that you don't know me, but I really would like to prove you that you can ignore basically all my CV, because the CV doesn't define what I am. So please, let's have a first conversation, and then you can decide. And if you really care about it, you can throw me any problem related performance and you believe that could be challenging, and I'm going to solve it. And let's see. So what has happened is that this guy answered and say, let's have a chat now. So I was in a train in that moment, and I say, okay, let's have a chat. I had the chat with Peter. And I go through the whole process. But at the end, I had the two options. So the Red Hat folks want me to work with them. And Azecast folks, I arrived did the latest check. And it turned out that even if I didn't work in the performance field, I was decent in that part. And I eventually picked a Red Hat for only one reason, because I had a friend of mine that was working there already, and he told me, Franz, here you got Ulrich Depper. That is one of the guys that wrote What Every Programmer Should Know About Memory. I know that you value knowledge. So you live for money like any other, but definitely here you can get something that money cannot grant you.
Mhm.
And I decided for Red Hat. And from that moment on, I never changed it. Because actually,
When was it in Red Hat? When was it?
9 years ago.
Okay.
Probably.
And what you're doing right now at Red Hat?
That's interesting. I started in the messaging field for a couple of years. I became the reference point for all related performance in the messaging field, including, and that's the funny part, I worked back in the same project I'd been rejected in C.
Mhm.
And it was super fun for me because I finally had the chance to work in production with C and break stuff. It was so fun. So I had fun for another year working there. And I eventually asked for more, to have the impact to work on performance field for the whole company, not just a single part of the field. And they trust me. So they got to talk with each other and say, Franz, this guy can do good stuff. Let's make it try and see what happens. So they made me try. I became the one caring for the Quarkus performance for basically the last 2 or 3 years. And from that moment on, I discovered at least two massive scalability issues. One is called the type pollution issue that is probably affected.
And now, Franz,
Yeah.
what I would like to do to stop here and re-invite you back, because
thanks.
now I'm working with Quarkus all the time, and I would like to talk just about scalability, Quarkus, OpenJDK, more deeply about your work. But we are already over time, but it was so interesting to me, so I didn't want to interrupt you, because even Hazelcast, this is also a shared story here, because on my blog, the Mr. Ozark, I think, right? This was he picked me whether Hazelcast should be open source or not, because because I had specific opinion about JCA Java connector architecture, and I said, okay, it is always good thing to have a standard connector to something, right? And we had the chat behind the scenes, and so this is also I always was in touch in Hazelcast over the years. And so this is why I didn't want to interrupt you too much, because it was too interesting for me. And we have enough agenda for the next time. Now, where people can find you, whatever you have, Blue Sky, Twitter, whatever.
I have both Blue Sky and Twitter. I think I'm forked Franz in both, with the underscore. With forked like forking in Linux. So and that's it. So you can find me there. On X is where I'm literally most of the time, but I'm on Blue Sky as well. I need to there are two different social. It's too stressful. I would like
so
to
what
what
I thought is, let's have a conversation with another Quarkus guy. What I didn't expect at all, your background. This was why it was so interesting.
Oh, thanks. Yes. I lived like a few lives in one life, but
Very
I'm
good.
happy about it. Yeah, it was fun.
Thank you a lot.